Okay, welcome back to Mad Best Wood, and now we've just got to a point in the course of the river that's actually a meander bend. Now if you look really closely on the far side there, we can see a slight dark shadowy area underneath the actual bank itself. That area there has been undercut. That's the outside of the meander bend, and the erosive power of the river has undercut that area. Of course, over time, continual undercutting will mean that that part of the bank will collapse and the meander will migrate further out into the distance. If we look on the closer side of the bank, right here, we can see there's much more deposition type material, fine sands, silts, clays, some coarse material. This is because here we have deposition on the inside of the meander bend where the flow is slower. Where the flow is slower, there's less energy. On the outside of the bend, the flow is higher, and there we normally have higher erosive power. So on the outside of the bend, we have what we call the thalweg, the fastest flow of the river. We have very high rates of erosion, hydraulic action and abrasion, and so on. On the inside, we have deposition. Okay, so when you do a cross-section of a meander bend, remember to think what that might look like. How would you do your cross-section from point A to point B? And what would that cross-section look like? Something like this. A steep river cliff and a gentle slip-off slope. And here you would have signs of undercutting. Today, the river flow is not very high. So these undercuts, if you like, were created at times when the river flow was more powerful, and that was probably in winter.